So this is problem from 2018. It's problem number 6, no calculator. And just by the glancing at it, the first thing I notice is it's a dy dx problem. Sometimes they might say like dh over dt, but I still call them a dy dx problem. It's basically giving you a derivative. And this is an automatic indicator also if they have some sort of a slope field. Okay? So we have a differential equation. A slope field for the given differential equation is shown below. Sketch the solution curve that passes through the point 0, 2, and sketch the solution curve that passes through the point 1, 0. All right, so that should be fairly easy. The only thing you need to be careful of is 0, 2 is way up here. They even put a point for you. All right, so that should flow if I'm going to the right. Should just take all the slopes that are right there. Just go that way. And if it was flowing to the left, then it's going to go just a horizontal line that we have, okay? And then the other one they wanted was 1, 0, and 1, 0 isn't here, it's that point. So we just basically want to flow with the curves, but you want to use that slope until you get to the next thing, then take the slope that's there. So one thing that sometimes I think students get a little messed up on is they start trying to flow through it versus once they get here, that should be our new slope, and it should be going directly that, and then we just try to smooth it out a little bit in the end. All right, so going to the left, it's going at that slope, and then once it hits here, it now acquires the new slope until it hits here on the axis, and then it looks like as it goes horizontally, it starts to now take that slope. And it looks like it's going to be pretty symmetrical as it's coming through here, and then it starts flowing off to the left. Clean it up just a little bit. All right, so that's definitely a part of a problem you want to see. If this were on the test, that's easy points, right? It's probably worth 2 points right there. Next part. Let y equals f of x. And my first thought is they're going to ask me to separate variables and then integrate both sides. But let's see what it says. Let y equals f of x, that just means y equals, be a particular solution to the given differential equation with the initial condition x is 1 and y is 0. Okay, so they're giving me an initial condition probably to solve for c. Write the equation of a line. Okay, so the question is different than what I was expecting. Write the equation of a line tangent to the graph of y equals f of x at x equals 1. So even though I might be able to separate variables and integrate, they don't want me to actually do that right now. They want me to get the equation of a line. Y equals mx plus b is what I'm going to look for. Looks like I already have a point, which is 1, 0. I just need a slope also. And luckily, they're giving me that right here. Slope is equal to, and what was the x value? Looks like x and y are needed for this. So x is 1 and y is 0. So a 1 is going to be right here, and a 0 is going to be right there, which is going to give me slope is equal to, or m is equal to, it's going to have a 1/3, and then times 1, which is kind of unnecessary, right? And then the last part is going to be 0 minus 2 is negative 2, and then square it, so it's going to be times 4. So m is going to equal 4/3, right? All right, so next part is I need to actually plug those in. You could go in point slope form, but I prefer slope intercept form, so I'm just going to do it. 4/3 x, and I'm just going to mentally do this. If I plugged in a 1 right here, if I put a 1 in that spot, what would the number right here have to be in order to end up getting 0? So in other words, here I have 4/3 times 1. I'm going to end up at 4/3. So I have 4/3 here, and I need to end up at 0, so I'm going to have to subtract 4/3 to end up with that y value of 0 that I wanted. All right, so final answer, I'm just going to, I guess that's clean enough. I'm going to go ahead and box that up. And I'm definitely boxing that up since it's worth points. I guarantee that's going to be worth some points. All right, I think there was a second part of the question. So they wanted me to write the equation of a line, and then they also wanted me to use my equation to approximate. So instead of using the graph and plugging in 0.7 and guessing where the graph would be, they want me to use this line that would be kind of like that coming through here. And it looks like it would be pretty accurate right here in the slope field until the graph of f of x started to veer away from the actual line. So it's pretty close near x is 1. But they want me to plug in 0.7 with no calculator. So I have y equals 4/3 minus 4/3. And I think instead of 0.7, I'm going to plug in 7/10. Just make it so I can just do some fraction action here. So I'm going to get 28/30, and then I'm going to make this one common denominator. So I'm going to say 40/30. So the final answer for y is going to be y is -12/30, which I think I could simplify, but I'm not going to. Both of them are divisible by 3. I think that's good enough, right? And it looks like if I was here on my slope field, if I went 0.7 to the left, I would end up at a negative value, some negative 12/30, I guess. Okay. All right, last one. Find the particular solution y equals f of x to the given differential equation with the initial condition x is 1 and y is 0. So this actually is the question I was expecting B to be. They basically want me to take this thing, let me write it down, dy over dx equals 1/3 x y minus 2 squared. They want me to separate the variables, which will probably be worth a point. They want me to integrate both sides, which will probably be worth a point. They want me to take this x is 1 and y is 0, plug it in, solve for c, and then the last part is, because they wrote that little portion, they want me to actually solve for y. So rearrange the thing so it says y equals and then a bunch of junk. So that's going to be my plan moving forward. This part, I'm just going to go ahead and take that dx and put it here. So I have a 1/3, I have an x, I have a dx, and I'm going to take this y minus 2 squared, and I'm going to throw it in the denominator, but I mean, really, I could just say it's to the -2 power. That might be more efficient. All right, so let me go ahead and clean it up a little bit. I'm going to say y minus 2 to the -2 power, or it's in the denominator, right? Dy equals 1/3 x dx, and they have to be attached by multiplication like that. And a lot of times, this is just y minus 2 in a denominator, like to the -1 power, which means the integral would be ln, because that's what I'm doing next. But in this case, I'm just going to have to use u substitution, but the u substitution is going to be pretty clean, so I might not really have to do it. All right, integrate the easier side first. This side equals the integral of x is x squared over 2, and the 1/3 is just going to make a 3 and a 2, a 6. And I'm going to throw a plus c right there. Okay? And the other side, like I said, I'm going to use the reverse power rule. So the power is going up, which means it's going to be -1. So I'm going to have y minus 2 to the -1 and then divide by -1, right? Okay. I could have a plus c2 or something, or a plus d, but I'm just going to leave it on this side because I would just move it to the other side. So from here, I just need to plug in x is 1 and y is 0. And I always plug in right away because that's the way their answer key is normally set up. So I'm going to plug in y is 0, so I'm going to get -2 to the -1 divided by -1. Now I'm kind of regretting that negative exponent, but 1/6 and x is 1, so the x is squared, which is just 1, plus c. 1/6, right? 1/6 times 1 squared is just 1/6. All right, from here, I want this to be, that's technically, let me just clean it up so it's not confusing. This is technically a -2 in a denominator, so times -2, just moving that piece down. So that's going to be 2, and I have 2 equals 1/6 plus c. And that 2 is going to be right there in the denominator, so it's going to be a 1/2. And then how do I get rid of adding 1/6? I'm going to subtract 1/6. So if I have, this is really, let's write 3/6, and I subtract a 6, so I end up with 2/6. 2/6 equals c, and this time I will reduce it because it's easy enough. 1/3. 1/3, box up the answer. All right, so the last step now is, because of that little phrasing right here, they want me to solve for y. So if I had this 1/3 in that spot right there, that 1/3 there, then how would I get y by itself? I think the first thing I would do is get this thing to be on the other side, right? So multiply by -1. Let's go ahead and do that. So I have y minus 2 to the -1 equals, right? To the -1 just means it's in the denominator. And that's going to be -1/6 x squared And then instead of a positive 1/3, I'm going to say negative 1/3. And the next thing I'm going to do is I'm going to flip the left side and I'm going to flip the right side, which basically just means raise both sides to the -1 power. So I'm going to have y minus 2 equals 1 over all of that junk, negative 16x squared minus 1/3. And I don't have to multiply everything by 6 over here or try to do anything fancy to clean it up. It doesn't have to be clean, it just has to be right. Last step is add 2. So y equals 2 and then plus 1 over negative 16x squared minus 1/3. So I obviously could have done some things to clean it up a little bit. I could have factored this negative out and then it would have been a minus sign there, or I could have multiplied both top and bottom by 6. Like I said, it doesn't have to be clean, it just has to be right. Okay? All right, hopefully that helps.